Hi grade 9s, these are the extra tutorials that I'm doing for you. So what we're going to do in this video is we're going to concentrate on finding the rule of a linear graph. Okay, so if we were given a data set of values, like so, we would know that once we've got these set of values, we can draw a graph. Then we can actually find the y-intercept, and we can also find the gradient, and then we can give the rule for that linear graph. So here we have a table of our x values. I'm going to put in our y values, so just as an example. So we've been given this example. What we need to do is we need to turn this into a graph. So what's important is you have a ruler handy with you, because we're actually going to plot this on the Cartesian plane. This is known as the Cartesian plane. It is important to label our axes when we're doing graphs. So our vertical axis is the y, our horizontal is x. Okay. What is also important to do, and why it's important to have a ruler, is that you need to make sure that each space between each number on your x and y are the same distance apart, to make the graph as accurate as possible. So I'm just going through. Making sure they're all the same distance apart. Okay, so for my scale on my x-axis, I have done a distance of 1 between each. So I've gone 1, 2, 3, 4, 5. On my y, if I had more room, I could change my scale, but I've done in tens, so I've gone 10, 20. You could actually go up in 5s. So what we're going to do is we're going to plot these points we have here. So we know x equals 0 at this point. So we're looking at x being 0, which is in the middle, so origin. What does our y equal? It equals 4. So on our y, that is roughly where our first point will be, at 0 for our x and 4 on our y. How you can make sure that you get each point correct is when we look at our next point, which is x equals 1, we go to x, where it equals 1, and we draw an invisible line vertically, or a dotted line. That shows that a point has to run along this line. Okay? What does our y equal? It equals 7. Okay, so we go across our y and we find where 7 roughly is. Draw a dotted line. This is where our next point should sit. So we follow that on. Following that same process, drawing that line for 2. So x equals 2 when y equals 10. There's our next point. Three and y equals 13. you can already see that we're getting a linear line, aren't we? We're getting this linear graph, this straight line. But let's keep going to make sure that it follows the same pattern. 4 is 16, and that's where we've gone up to. So now, once you've got your points, you can draw your straight line. So this, putting these values onto a graph, is known as plotting, okay? You're plotting the points on a graph. So if you're asked to create a graph, or you're asked to plot points, this is what you'll be doing. You'll be given a set of values, and then you need to plot them on your graph. So that's the first step. What can we get from this graph as well? Okay, well, we know that a straight line, the equation is, the generic equation is y equals mx plus c. Okay, y equals mx plus c. What does c equal? So let me rub this graph out now so that you can see this better. What does our c equal? That is known as our y-intercept. Our y-intercept is where the graph actually hits the y-axis, okay? Our m represents our gradient. So if the number is positive, where m is, it's a positive gradient. If our m is negative, like -2, then our gradient is negative. Okay, that should make sense. How do we find our y-intercept? We can always find our y-intercept when x equals 0. Okay, so you always find the y-intercept when x equals 0. How can we find our gradient? There's a rule that we can use to find our gradient. Okay, so let's now find our gradient of this linear equation, because we know it's linear. We've drawn a graph, shows that it's linear. Okay, but we can prove it by making it into a rule that follows the linear equation. Okay, so what is gradient? It's represented by the letter m. So how do we find gradient? Rise over run. What that means is, in a graph, like so, if we've got 2 points on a graph, we're looking at the change in y over the change in x. So let me draw that here. 2 points, the change in y, the vertical, over the change in x, the run, which actually gives you a triangle. Okay, so it's the change in your y value over your change in x. If we have 2 points, our rise over run just looks like this. M equals y2 take y1. So y2 represents just the y value in our second point. Our y1 represents the y point in our first point that we've chosen, over x2 take x1. Okay, so if we've got 2 points on a graph, so here, say this is 0, 2. So our x always goes first, doesn't it? Our x coordinate goes first in our ordered pairs. So this would be our first point on our graph. So we would label this x1, y1. So say we've got, we'll say that's 0, 4 actually. And say this is our next point, which is at 1, 7. We'll label that as x2 and y2. Now all we have to do is put those numbers into our equation. So what's y2? Well, it's 7 from our second point we've selected. What's our y1? That's from our first point, our y value in our first point, which is 4. You can pick any point on a graph. It's easier if you normally pick your y-intercept and another point. So what's our x2? Well, our x2 is 1. And what's our y1? Our x1, I should say, it's 0. So what is 7 take 4? Well, 7 take 4 is 3. So now we have 3. What's 1 take 0 is 1. Make sure you're always doing your equal signs. So what does m equal? It equals 3, because 3 divided by 1 equals 3. So we know that our gradient equals 3. So we've worked out our first part of our rule, which, remember, a linear equation is y equals mx plus c. So we found out our m. So y equals 3x, and we haven't got our c yet, have we? But we found out what our m equals. All we have left now is to find our c. Now remember I said our c is our y-intercept. In this set of tables, we've been lucky enough that we've been given our y-intercept, because x equals 0 up here, y equals 4. So we know that our y-intercept is 4. So therefore we have to have y equals 3x plus 4. This is our rule for this table. If we were not given x equals 0, what can we do? Well, remember, this y here represents your y coordinate, any of these in the table. Your x represents your x coordinate, so any of these in the table. So we could actually substitute a pair into the equation to get c. Okay, so let's do that actually. So say we're going to have y equals 7. And when y equals 7, what does x equal? It equals 1. So let's substitute that in. Okay, what we can use is, well, first we need to see that 3 times 1 is 3 plus c. What can we do to get c by itself? We can use some algebra. Okay, so let me rub this out now. So we're at this stage, 7 equals 3 plus c. What can we do to get c by itself? We can take the 3 across. Remember, this 3 is positive, so when we take it over to the other side, we're doing the inverse operation. So positive 3 becomes negative 3. So 7 take 3, okay, instead of plus 3. And that gives us c. So what's 7 take 3? Equals 4, which is c, which we already identified from our table. Okay, so that's how the gradient and that's how using our gradient and working our y-intercept will give you an equation of a linear graph that you're looking at. And the data set really assists you in that one. So I hope that has helped. Thank you.